Good morning. Today I want to go into a little more of bias and its relationship to distortion, or how bias can affect distortion, might be a better way to put that. There are some amplifiers that actually have you set the bias using a distortion analyzer. I'll get into that a little later. But what I'm going to do this morning is I have a small little monoblock amplifier. It's a Yamaha MX-M70. I can't find anything about it online. I don't think it was one of their more popular pieces, or maybe a later piece. But anyway, I've dialed its bias down as low as it'll go, and I'm running a 20 kilohertz low-level signal in. I want to exaggerate the crossover distortion so you can see it and see how turning the bias makes it go away. We're going to take a look at the distortion analyzer in the process, and you'll see the relationship is clear. So give me a moment. I'm going to move everything into place so you can get a better look. Okay, I thought I'd mix things up a little this morning, so I'm going to use the digital scope, and we're going to take a look at a 20 kilohertz low-level waveform, and you'll clearly be able to see the crossover distortion. Right now you can see that the bias is less than 1 millivolt. That's actually 900 microvolts. And since I can't find any documentation online, we're going to calculate what the bias should be, what the millivolt reading should be, to yield a 30 milliamp bias. Anyhow, I'm going to put some signal in. You can clearly see here and here the crossover distortion. So I'm going to turn the bias up just a little bit, and you'll start to see it disappear. Okay, you see those notches going away? That's about where we want it. Starting to lose trigger here a little. But yeah, you can see those notches are gone now. I'm going to turn the signal off. And we have a bias of about 3.1 millivolts. Now, I've calculated this. I'm going to tell you right now, that's low compared to what it should be. So here's what we're going to do. We're going to turn this back down, and I'm going to focus on the distortion analyzer. Let's see here. Put our signal back. And we're looking at about a 0.67, call it 0.7% THD. Now I'm going to dial this back down again. By the way, if you're looking at the meter, when you feed signal in, you can't get a good DC reading. So now I'm going to dial this away till the distortion is just about gone. Let me just, you can see that's right there what we're trying to dial out. And as we do, you can see our distortion dropping. It's about 1/10 of what it was. Alright, so I'm going to turn the signal off. And if we look back down here, you can see our bias is still very low, which is why I don't care to use the distortion analyzer method. And I'm going to turn this back down and show you. How we zoomed in here. We just want to see these notches. Okay, so I'm going to dial that down till that is gone. And there, that should be good, but I can tell you it's still a bit under biased. Notches are gone. Looks like a good clean sine wave. Okay, I'm going to stop it here and we're going to look at a few things. Okay, so what should our bias be? Well, rule of thumb is about 30 milliamps. So that's what I'm going to shoot for. Our emitter resistor's value is 0.22 ohms, and we have two of them because there's two output transistors. We generally just measure between two of them if there's more than two. We calculate the millivolts across both emitter resistors. The formula is millivolts equals R times I. I is current. So the millivolts, to calculate the millivolts, we need to do 0.44, which is our two emitter resistors, times 0.03, which is 30 milliamps. And that yields us a reading of 13.2 millivolts. Now if we look at our meter, we're only reading 6.9. Okay, so we want to dial that up till we get about 13. And that's close enough, and that should be a good bias for this amplifier. Now, if your amp runs hot and you can dial the bias up until the notches disappear at 20 kilohertz, you should be good. I think I mentioned I did a Marantz and I dialed up the bias per factory specs, and it ran way too hot. I'm waiting for the owner to bring it back. I'm dialing that back down because the amplifier runs stupidly hot. I'm afraid it's going to shorten the life of the outputs. Even though he says he fan cools it, I want to set it down a little bit. So anyhow, that's all I have to say on this subject right. Oh, before I close, let me just say there's several different ways of setting bias. Now to me, the gold standard is measure across the emitter resistors, because that's where the rubber meets the road. You want to know how much current is going through your outputs. Okay? Some manufacturers have you pop the fuses out that feed the output stage and measure the current going through the fuse, or where the fuse would be. You're going to shunt it with your meter. That's the entire output stage. I'm more concerned with the output transistors themselves. So again, I like measuring across the emitter resistors. Some manufacturers have you measure the AC wattage that your unit's pulling as you adjust the bias. Again, that's, to me, not as accurate as measuring across the emitter resistors. And I mentioned setting it with the distortion analyzer, which any of these methods I think will work, but I think if you want the optimum, or if you really want to know what's going on, you're going to measure across the emitter resistors. And that's all I have for today. I hope this video finds everyone well, and as always, I enjoy giving back to the community that has given me so much. Thanks a lot. Have a great day.